Hello, welcome to another lesson. In this lesson, it's a little different from what we covered on the previous video. The previous video was all about percentages and things like that. Well, now we're going in a totally different direction. It's a different section of review of basic algebra into the world of functions. So before we talk about actual functions and what they are, we're going to talk about relations and what relations mean. And more specifically, what does a relationship mean or a relation mean in terms of, ordered pairs or sets of numbers. So to put it simply, relations are sets of ordered pairs in the form x and y. So the x coordinate or the x value comes first, and then we have a y value. For example, here we have a set of x values. Let me color code this. Set of x values and then a set of y values. The x values, the set of all x values, is called the domain. And the set of all y values is called the range. And generally speaking, when we have functions, the domain values will be used to calculate range values, but that's not always the case. But domain and range can be thought of as input and output. So for example, maybe I start with a 1, and it gives me the number 3. When I stick it into, say, our function or our machine later, stick it into our relationship, it gives us a 3. Maybe the number 5 gives us the number 7. Maybe the number -1 gives us the number 3 as well. Who knows? But the idea is that there's this input and output, this domain range. So very broadly speaking, the domain is generally considered to be an input style, things that we put into functions or relations. Range is, again, generally speaking here, making generalizations, range is going to be an output. So let's actually see this in the context of an exercise. So this exercise says to state the domain and range for this relation, which is the same relation we saw on the previous page. The previous example, the stuff I wrote at the end was just a little example off the top of my head. So the domain in this case are all the x values. So I'm just going to list them. I'm going to use these curly brackets just like they've used. And I'm going to write down all the x values. And this is all of them. There's only 4, so I'm going to close that set of square brackets there. And again, it is called a set. That'll come up a lot later in the course, but the curly brackets here generally denote a set. It means that we have a set of numbers, and they might follow a special rule. And generally speaking, we should write these in low to high order, or numerical order. So -2, 0, 2, and 6 would be our numerical order. So numerical order is preferred. It's not necessary, but it is the way that the standard by which we follow usually for these numbers. And the range follows very much the same way. You can pause the video and try to get it yourself and compare your answers to me. Whoa. So that would be what I got for just listing the range values, and I'm going to list them now in numerical order. And there we have it. So everything in the domain and the range should be counting for all the x and y values here. And again, the domain are all the x values and the range is all the y values. And this little circly thing on the side is, I guess you could call it an input and output or domain and range diagram, whereas the domain values would go over here, the range values would go over here, and then we write in the values of the domain. So we have -2, 0, 2, and 6. In the range, the values we can get are -3, 1, 1, and 5. So there's actually something interesting to notice here. We've got 1 twice. So there's no reason to repeat a single digit when we're writing the range. So really the range of this, the possible outputs for this relation or relationship, you can only get 3, 1, and 5. There's no reason to write 1 twice. So what I'm trying to say here is repeating a number is not necessary. No need to repeat digits or numbers. I should call it a number. Okay, so two things. Numerical order preferred, no need to repeat numbers. And this little diagram tells us what things are mapped to what. So 0 is mapped to 1. So let me look at this. 0 and 1 are related. So we can take 0 in the range, and it maps, 0 in the domain, and it maps to 1 in the range. Let's see what 2 maps to. Well, 2 maps to 1. If we put in a 2, we get back 1. If we put in a -2, we get back a 5. And if we put in 6, we get back -3. And so this is just a bit of a mapping diagram. It shows that when we put in certain x values or domain values, we get back certain y values or range values. And in this case, it's important to take a note of this. We've got 2 x values mapping to a single y value. This is okay. We'll say this is a function. I'm getting ahead of myself, but I wanted to make a note here. And the note is that if different x values map to a single y value, for example, 2 different x values give a single y value, that's okay. But the opposite is not. We are never allowed to have the same x value giving a different y value. That would be considered not a function. So really, for clarity, I should make this green so that, green is good, and then maybe we'll see some red for red is bad. But that's the basic idea behind these functions. So first I wanted to talk about functions themselves. Functions are a special type of relation. So I guess I just said that they were functions before, but really we were talking about relations. Now we're talking about functions, where each element in the domain is paired with exactly one element of the range. So you put in a domain value, and it'll give you one range value back. So in this case, this one maps to this maps to that, this maps to this maps to that. That would be a well-behaved function. A poorly behaved function, it's just a stupid joke really, but this x value maps to this maps to this, and so on. They all map to a single value. That's actually okay. They're still a function, but yeah, it's silly because they say it's poorly behaved because they just all go to one value. Anyway, I don't want to over-explain that joke, but two different types of functions really. Ones that map to the same y value and one that maps to different y values. But in other words, functions are like little computers. They take inputs and they produce outputs. A given input always results in the same output. And if you want to go to explore this a little more, you can go to PhET, follow this link, and you can actually make your own functions. But that's over and above what we need to cover today. So some exercises. If f of x, that's how we pronounce it, if f of x, if the function f, which takes the values x, equals 5x, then find the values. So we actually kind of dealt with this before evaluating functions. We have when x is 3, what's the final answer going to be? Well, normally it's 5x, right? F of x, so anytime you saw that x, replace it with 3. It's 5 times 3 is 15. Let's do another thing. If f of x is 5x, well, 5 times x, so in this case 5 times 8, because we're using the same function, different x value. So it's the same rule, 5 times something. So in this case where something is 8, 5 times 8 gives 40. So the same function takes different inputs and gives us different outputs. For the second case, the second question here, the second exercise, I'd like you to try this. You can pause the video and check it out for yourself, see what it's going to be. These are pretty straightforward. The function is 2x plus 1. In this case, our x is 5. So if we put 5 into this, what do we get? Well, 2 times 5 plus 1 gives us 10 plus 1, which is 11. In the case of 2, remember our original function is 2x plus 1. Our rule is multiply the number by 2 and add 1. So I take our number and multiply it by 2 and add 1. In this case, it's 4 plus 1, or 5. So you can think of functions like a little machine, okay? you've got your input, you've got your function, which in this case, for this little machine here, the function will take it, take your number, multiply it by 2 and add 1, and then it'll spit out an output. Functions are just rules that take numbers, do things to them, and then spit out an output. So really the function itself, we don't really need to worry about the x. The function takes the number, multiplies it by 2, and adds 1. Or the previous one here, 5x, we have our input and our output. It just multiplies it by 5 and gives us an output. So in short, functions are little machines. They take inputs, produce outputs. So all these questions asked were the answers that I gave. But I just want to go one step further and draw a couple of function diagrams here. I'm going to do, this will be my inputs. This will be my output, or domain and range, whatever way you want to put it. In this case, putting in a 3 gave us 15. Putting in an 8 gave us 40. And we can say that this is well behaved. Right? It's well behaved because we don't have crossing of lines, we don't have values repeated or anything. In the second case, same thing. The number 5 gives us 11. Number 2 gives us 5. It's a well-behaved function. Let's see an example of something that's not so well behaved. So what is not a function? Well, a relation or equation that gives two different answers for the same input. Again, it's not saying two different answers for the same output or two different outputs for the same input is not a function. So let's consider x equals y squared transposed for y. So what it did, just let me talk you through it. I know it's right there, but they take x equals y squared. They did the square root of both sides. We're solving for y, okay? Square root of both sides, that's actually plus or minus. To be really specific, that's what the answer is. So y is plus or minus root x. Okay? So that's actually our function. It's going to be plus and minus root x. Is our new function, okay? So what if we put 4 into this function? If we put 4 into this function, we get plus or minus root 4. And the answer then is plus or minus 2. And very literally, the value of this function when x is 4 can be 2. And when you put in 4, the value of the function that comes out is also negative 2. So you get 2 outputs of the same input. Or to be specific with the terminology above, you have 2 different answers for the same input. You put in 4 and we're getting 2 different answers. So this is definitely not a function. Let's do a quick map here. 0 if we put in, if you put 0 into this function, you would get 0. If you put in 1 to this function, you get 1. If you put 1 in, you also get negative 1. 4 gives 2. 4 also gives negative 2. Let me draw my little diagram here. Let's find some space. Okay. If you put in 0, let's put all the possible inputs, all the possible outputs, okay? Just to make it simple. All the inputs, 0, 1, and 4. All the outputs, 0, 1, negative 1, 2, negative 2. Let's see what maps. Let's see what we can see visually. 0 maps to 0. That's okay. 1 maps to 1. 1 also maps to negative 1. That's bad. That's very, very bad. And 4 also maps to 2 different things. That is not a good thing. We're allowed to have 2 inputs mapping to a single output. So in this case, back here, notice the difference. Pause the video on that, take a look at it. It's 2 inputs mapping to a single output. That's actually okay. It's just not well behaved, like this. Still a function, but the opposite is not true. If you see 1 input mapping to 2 outputs, then your function is kind of broken. Certainly, it'll be like making a piece of computer code that every time a person typed in a number and wanted to calculate something, they give you different values. It's like I type in, how much is my mortgage going to be, BMO mortgage calculator? And it gives me 10 different answers for the same input. That would be a broken machine, okay? So things that are not functions are not very useful for making calculations with, at least not in the traditional sense. So long story short, y equals plus or minus root x is not a function because we have two different answers for the same input. All that's left now is for you to try some practice problems. There is just this page of practice, but I'd like you to try it. I'm going to put down my final answers, and you can compare it to yourself. You know, compare it to your own work. And if you need this explained in any other way, you just let me know. Bring it up in class. And here are the answers. I probably should have put them up before I started talking, but it is what it is. C'est la vie. So this is the kind of thing you should be expected to do. There is one more practice set after this. I just wanted to show you the answers to this. So work through these. And then the second practice set, I'll show you the answers. You know, you can pause the video and check it. Okay, and here are my answers for this. So take your time, make sure you do it yourself, check against mine. I'll just make a couple notes on what I did throughout this process. For the first question here, this one up here, notice that when I first wrote them down, I just kind of did a lazy way. I just did all the domain values, listed them, listed all the range values. But then as my second step here, I made sure to cancel any duplicates. For example, I canceled the 3 for the domain and the 2 for the range, and I put them in numerical order. And then I drew a little diagram to convince myself that no, this was not a function. But there was a warning flag anyways, because if you've got a 3 giving a 4 and a 3 giving a 5, that's two different outputs for the same input. That can't be a function. In the second case, if you've got only repeated range values, I'm talking about down here, if you've only got repeated numbers in the range, that's okay as long as you don't have repeated domain values. And so this diagram over here looks like maybe it's not a function, but it is, because we don't have this one single domain splitting into two different range values. You can see they're all very well behaved. They all kind of go in one place only. And then the third situation took a little bit of thinking to work out. You didn't actually have values to work with, but the relation was that it takes an x and triples it. So really the function, or the relation, is 3x, right? Yeah, of course that's a function, because no matter what number you put in, it's going to give you a different output. So directly maps to a triple of it. So definitely a function, no issues there. You're always going to get a really reliable rule, or reliable answers for this. So that's all there is to this function section. The next section we're going to move on to will be scientific notation. This is enough for today. Keep track of any questions that you have, and we can go through them in Wednesday's class. All right, that's it. All the best. See you next time.